indices. We've already learned that 3 raised to power 5 means 3 times 3 times 3 times 3 times 3. 2 raised to power 4 is 2 times 2, 4 times. The superscript numerals 5 and 4 are called indices. In singular, it's called an index. In general, a raised to x is equal to a times a times a x times. For example, 16 is equal to 2 times 2 times 2 times 2, which is equal to 2 raised to power 4. 81 is equal to 3 times 3 times 3 times 3, which is equal to 3 raised to power 4. 125 is equal to 5 raised to power 3. We can represent this information on a tree diagram as shown below. Laws of indices. Rule 1. Multiplication. When indexed numbers with common bases are multiplied, we simply add the powers. That is, 2 raised to power 4 times 2 raised to power 6 is the same as 2 raised to power 4 plus 6, which is 2 raised to power 10. 3 raised to power 5 times 3 raised to power 2 is the same as 3 raised to power 7. 4 raised to a third times 4 raised to a third is equal to 4 raised to 2/3. In general, a raised to n times a raised to m is equal to a raised to m plus n. Rule 2. Division. When indexed numbers with common bases are divided, we simply subtract the powers. That is, 3 raised to power 5 divided by 3 raised to power 3 is equal to 3 raised to power 5 minus 3, which is equal to 3 raised to power 2. 4 raised to power 7 over 4 raised to power 2 is equal to 4 raised to power 5. In general, a raised to n divided by a raised to m is equal to a raised to n minus m. Note that the bases must be the same, otherwise the multiplication cannot be done through addition of the powers. That is, 3 raised to power 4 times 2 raised to power 3 cannot be simplified further. Rule 3. Power of 0. Any non-zero number raised to the power of 0 is 1. That is, 10 raised to 0 is equal to 1, 25 raised to 0 is 1, a raised to 0 is 1, x raised to 0 is 1. Rule 4. Negative indices. A number raised to a negative index is the same as the reciprocal of the equivalent positive power of the same number. That is, x raised to negative a is equal to 1 over x raised to a, meaning 2 raised to power negative 5 is equal to 1 over 2 raised to 5. 5 raised to negative 5 is equal to 1 over 5 raised to 5. The reverse of this is also true. That is, 1 over x raised to negative a is equal to x raised to a, meaning 1 over 2 raised to negative 3 is equal to 2 raised to power 3. Rule 5. Powers of powers. When a number is written in index form and it is raised to another power, the indices are multiplied. For example, 2 raised to power 3 in bracket raised to power 2 is equal to 2 raised to power 3 times 2 raised to power 3. We add the powers and we get 2 raised to power 6. We could rather have done simply as 2 raised to power 3 times 2, giving us straightly to 2 raised to power 6. 4 raised to power 5 into bracket raised to power 4 is equal to 4 raised to power 20. Generally, x raised to m in bracket raised to n is equal to x raised to power m times n. Note that all numerals multiplied or divided together in a bracket are raised to the power of that bracket. That is, 2 times 3 into bracket raised to power 4 means 2 raised to power 4 times 3 raised to power 4. 2 over 3 raised to power 2 is equal to 2 squared over 3 squared. Generally, x times y to power m is equal to x raised to m times y raised to m, and x over y raised to power m is equal to x raised to m over y raised to m. Rule number 6. Fractional indices. Consider 4 raised to power half times 4 raised to power half. This is equal to 4 raised to power half plus a half, giving us 4. Also, root 4 times root 4 is equal to 4. Considering equation 1 and 2, it follows that 4 raised to power half is equal to root 4. 3 raised to power half is equal to root 3. Equally, 5 raised to a third times 5 raised to a third times 5 raised to a third is equal to 5 raised to a third plus a third, giving us 5. Also, cube root of 5 times cube root of 5 times cube root of 5 is 5. Considering the above two equations, it means that 5 raised to a third is equal to cube root of 5. Generally, x raised to power 1 over n is equal to nth root of x. Simple equations involving indices. For example, find x in 3 raised to power x is equal to 9. In our solution, express the right-hand side in index form. That is, 3 raised to power x is equal to 3 squared. Since the bases are similar, we equate the powers, and therefore x is equal to 2. In another example, 3 raised to 2x minus 1 is equal to 9 raised to 2x plus 2. In our solution, 3 raised to 2x minus 1 is equal to 3 raised to 2 times 2x plus 2. Equating the indices, we have 2x minus 1 is equal to 4x plus 4, and x is minus 5 over 2.
If you want to go on and major in math or do honors in math or do a career in math, you really do need to be good at it. But I think too many people stop out too soon because they've had bad experiences. I think math teachers have a lot of responsibility for that. We haven't taught it so well. We haven't provided the resources that people need. And so I think if you need help, you need to get it, and you need to get it early. And you need to work at it.